Hello, sixth grade scientists. So today we're going to have an investigation on solubility. And remember, solubility is a physical property that describes the ability of a solute to dissolve in a solvent to create a uniform solution. And we've talked about how sugar has a high solubility. It dissolves very easily in water. So did our lemonade drink mix. It dissolved really easy in water. So we know that a solid solute, if you increase the temperature, you increase the solubility. So when the temperature of a solvent is increased, the more solute can be dissolved within the liquid. If the solvent temperature is decreased, however, the less solute can be dissolved. So that's true with the solid, but what about a gas? So we have these bottles of pop with, they're made of water, carbon dioxide, high fructose corn syrup. So we've got the soda pop already ready to go with the gas already inside. So if I put these in these different, I've got ice water, room temperature water, and hot water. If I put those in there, which one will allow the gas to escape, which means it has less solubility, so the solubility has been affected, and the gas then is escaping because it is not, it is allowing it to escape instead of holding that in. All right, so we need to start our procedures, and it says to stretch the balloons to make sure that they're going to be able to stretch to show whether the gas is escaping or not. And I've got my 3 balloons, but I also have extras just in case. Now it says to open 1 bottle at a time and quickly put the balloon over it. And you'll notice, you'll hear it when I open it. That has to do with the gas. The gas is going to start escaping, so I've got to have the balloon ready and quickly put it over top. So there I've got the 1 all set, ready to go. And I'm doing 1 at a time. And now I'm going to do the second one. Hopefully none of these have been dropped so that I get pop blown in my face. That wouldn't be very good. All right, and then the last one. Okay, each one of them I had that crack. All right, so I've got the balloons placed over each one of these. All right, so now I'm going to go ahead and I'm going to place one of them in the room temperature. So this is the room temperature. So I've got my root beer to go in the room temperature. And then I've got my Sierra Mist going in the hot water. And I've got my Coca-Cola going in the ice water. All right. So now it says that next it says to wait for 5 minutes. So while these are working, and I'm already noticing something happen, I don't know if you're noticing it too. And I noticed too, the bubbles are a lot more in the Sierra Mist than they are in the room temperature or in the ice. These bubbles, there's bubbles there, but this one's really bubbling. This one's really bubbling up. So I don't know if we're going to have to wait the full 5 minutes. I'm afraid the balloon's going to pop. But the next part, once we notice the change, and once we've gone through this for about 5 minutes, then we're supposed to wrap a string around the widest part of the balloon and measure the circumference of the balloon. So we'll do that, and that is part of your lab. So that is something that we're going to do. So while we're kind of waiting and watching to see what's happening, and I notice already there's a change in the one, but I'm noticing that each one of them does look different. So each one is affected by the temperature. The solubility is affected differently. So it'll be interesting to see exactly how different it is when we measure. And I've got my string ready to go to measure. And we still have 3.5 minutes. So I've got my string to measure, and when I measure, I'm going to take my string and I'm going to measure the wide part, the widest part around the balloon. I'm going to make a dot or a line of some kind with a marker, and then when I pull it away, then I can measure it with my ruler to tell the circumference. So well, I'm noticing this is a little bit, and this is just a tiny bit, but I think that was just from the crack of it, from me initially opening it. Now, this one is still bubbling a little bit. The Coca-Cola bottle is not bubbling at all. So those are just some things. Now this Sierra Mist is just bubbling and bubbling and bubbling. So there's a reaction of some kind going on here. So I'm sorry if my cat jumps up here, but he is eyeballing the balloons and he's kind of wanting to play with them. So if you see a little orange cat, that's what's going on. So the string will be the way for me to measure to see exactly how different these balloons are in size. So as we're waiting, if you take a look at where it says the results, the balloon circumference, that's where you're going to write down these results in that table right there. And I'll measure this. Now, feel free to do this again at home and see if you get the same results. Now, I think this balloon is actually blowing up a little bit more, so the gas is still escaping. So we've got the hot water, the room temperature water, and we might have a little bit going on here, but it's not bubbling as much as it was a little bit ago. But the ice water, the Coca-Cola is not bubbling at all. So I'm noticing a difference. All right, so then when we're finished with this, then we write the things in the table. Then there are some questions that I want you to answer. Which situation made the most gas escape? Did it match what happened with the solid? And you'll have to go back to the background information to answer that one. Or how was it the same, or how was it different? So if you say that it did match, that the increase in temperature increased solubility, which means it increased how much it kept in, or if it does not do that, because the temperature increase doesn't seem to be keeping the solution together. It seems to be separating it. So my Sierra Mist might not taste so great after this, because I might have flat pop. But that's okay. All in the name of science. So you're going to be looking at that, and then there's also another question for you to answer on the opposite page, on the third page. Okay, 5 minutes is up. My timer went off. Okay, so let's start with the ice water. So I'm going to measure the circumference, the widest part of the balloon. And I've got to, would be nice if I took the cap off because I can't do this one-handed. I might have a cat helping me with this. So if he jumps up here, don't be alarmed. I think he's a scientist in the making. Okay, so I'm going to mark that on the string, and I've got the string for the cold water. The string is 5.5 inches. So for the ice water, it's 5.5 inches. All right. So let's see here. 5 for the ice water, 5.5 inches. All right. So now let's go to the room temperature. Whoops. I know, Simba, doesn't this look interesting? All right, so I'm going to mark that. It's a little hard for me to hold on to. So with the room temperature water, we've got 7 inches. So the circumference is more, the circumference is bigger. So some of the gas did escape from the room temperature water. So I'm going to go ahead and write on my paper too, 7 inches. Okay, with the hot water, we've got, okay, let me mark on there. All right, so I've got it right to there. Oh, wow. 11 3/4 inches. So 11, let me write that down. 11 3/4 inches. All right, so there is a big difference between the ice water, which was 5.5 inches, the room temperature water, which was 7 inches, and then the hot water, which was 11 3/4 inches. So what I would like you to do, I would like you to answer the questions. So I went ahead and I filled in my part of my sheet. And I want you to answer these 3 questions that go along with the results that we just found. And then I also want you to draw a conclusion. So in the conclusion, what you can do is you can go back to the background information and write a statement that is true with the gas. So, for instance, for a gas solute, when you increase the temperature, you decrease the solubility because the gas starts to escape. So it's actually pulling away from the solution. So remember we said that a solution, see, I told you my cat would get involved. So remember we said a solution can be broken down into its parts again? Well, that's what we're doing here when we're adding temperature to this. So we are taking away from the solubility, okay? So the increased temperature does change the solubility. All right, so I want you to draw a conclusion. Now, also on the back, I wrote down a real-world application to this. So the solubility of gases also plays a role in the survival of fish. Since an increase in temperature causes the solubility of gases to decrease, water at high temperatures lacks dissolved oxygen. Many fish are only able to live in cooler waters where there is more oxygen. So that's kind of a little real-world application to the information that we have here. Oh, look at this. As the water, I guess, is getting warmer, there's more gas escaping. Even in the ice water, the gas is starting to escape more. And this, too, the balloon is still getting bigger. So, I'm going to let this sit on here another 5 minutes, and I'll remeasure, and I'll let you know tomorrow what happens with the balloons. All right? So, go ahead and fill out your lab, and I will see you tomorrow. So, keep watching, keep thinking, always stay curious. See you tomorrow.